Welcome Science 9. It has been a while. Today, this lesson video, it's a summary of 5 different reactions types and how you can balance chemical reactions, which theoretically doesn't play a huge role in grade 9, but it's really helpful for your Science 10 journey, which is going to happen in a few months. Also, I like to go through some of the evidence of chemical reactions because we are currently not in a good situation for the lab. So that's why I'm gonna go through evidence of chemical reaction, then followed by reaction type, then balancing chemical reaction. There are 5 different chemical reactions, and also there are 5 evidence of chemical reactions. So if you see any one of those, you can assume that, oh, there is a chemical change, not physical change. One of them is if I mix chemical A and then chemical B together, you see some kind of a color change. What you see in this picture, as an example, you have a pink solution, but let's say this pink solution is solution A. And you have some chemical that is colorless, that is B. While mixing those, you may notice that there is a complete different color that is coming out as a result of mixing up A and B. This color change is our evidence of chemical reaction number 1. The second type of evidence of chemical reaction is a bit unique type. I need to elaborate a little bit. For example, if I have a chemical A and there is chemical B. Order doesn't matter. Imagine you're mixing A and B. The thing is, previous one the volume increased, but the color changed. But for these type, you may see some kind of solid formation and it become what I like to say precipitation. That is evidence of chemical reaction number 2. A solid forms when a solution of sodium dichromate, which you don't know, it's a solution that you see orange color, and there's a lead nitrate, which is colorless solution. When you mix those together, can you see the cloud looking formation? It looks cloud, but it is actually powder form of a solid. So our chemical reaction, the evidence of chemical reaction number 2, I like to say solid formation, which in other words, precipitation. The third example is what we know the most, if you will, or what we have been seeing the most whenever there's a chemical reaction. It is a bubble formation. So let's think about this bubble, if you will. Bubble means there is gas molecule that is escaping. From scientist perspective, that means if there's a chemical A mixing with chemical B and there's bubble, that means there's some kind of gas is forming. Solid, they sink. Gas, do they sink? The answer is no. Gas tends to escape because they're very not dense, they're very light. They try to escape the solution. So our third evidence of chemical reaction is, I like to say, gas formation, or sometimes people say bubble formation. The fourth example, which a lot of my students like, and it's one of my favorite too, even though it's the most dangerous one, it's known as whether something can be combustible or not. Let's talk about burning things a little bit. Um, how can scientifically, how can we define if something is combusting? Well, combustion always involves one of the gas called oxygen. When oxygen is combined with the high heat and it produces some kind of flame or some kind of a heat source, we call it combustion reaction. So I like to say evidence of chemical reaction number 4 is if something is combustible or not, which means you need oxygen gas and produce some kind of flame, if you will, burn, etc., etc. The fifth and the last evidence of chemical reaction, which you learned in the previous science, is known as heat. What I mean by heat is there are two situations. So number 5, I like to say it is a concept of exothermic or endothermic. Exothermic means there are some chemical reaction that release heat. Think about it like a heat pack. There are some that absorbs heat energy, which think about it as a cold pack. Either way, chemical reaction either involves heat as a mean of energy to proceed a chemical reaction, or they produces heat as a result of a chemical reaction. So the last one or fifth one I like to say is involvement of heat energy. And there are two scenarios, like I said, either drop up the temperature, which is known as endothermic, or raise up the temperature, which known as exothermic. And we can measure that temperature change using thermometer. Now let's talk about 5 different types of reactions. I don't really recall making a lesson video regarding this. Let's go with our basic one. The very first one is known as formation or synthesis type of chemical reaction. So how can we determine if something is synthesis or formation related reaction? So let's think about the words first. Forming something, synthesize something means making something or building something. If you're playing Lego pieces, so imagine you want to build a Millennium Falcon. You need probably close to several hundreds to thousands of Lego pieces to build that one model. I want you to think that as an analogy for this type. In grade 9 science, you do not need to balance the chemical reaction. You don't even need to make a chemical using chemical symbols, chemical formulas, if you will, to make the reactants and product. But here's what you need to do. Let's talk about the basic. Chemical reaction is always separated by this arrow that's facing or going towards right. Left side, we call it reactants. It's like ingredients that you need for cooking. Then we have something called products. In formation or synthesis type, you have elements only. You are adding bunch of elements. So imagine these elements are Lego pieces. Normally in Science 9 you have two. We call it binary. Ionic compound or molecular compound. Binary means two. You generally need two type of elements to make something. However, it can be more. So elements plus element plus dot dot dot. What is important is, let's say hypothetically we have elements A, elements B. It may have element C, but let's say easy one first, A and B. You're using those to make a product, one type of product, which I like to say compound. A compound. What I mean by that is, if I mix A and B, I make a product called called AB, which is a combination of elements 1 and 2. So we give my last element, my last product, combination of A and B, which is compound. A good example of this is, for instance, if I have hydrogen adding with oxygen, if we make water, this is an example of formation or synthesis type of reaction because hydrogen is element H2, oxygen is element O2, water is H2O. We are using hydrogen and oxygens to build water. So this is a type of formation or synthesis reaction. There are other examples that I can do. Like for instance, I have nitrogen and I have hydrogen. One of the molecular compounds that I advised and highly recommended to memorize was ammonia. Because nitrogen is N2, hydrogen is H2, ammonia is NH3. None of them are balanced. In Science 9, you need to know this level and identify. Oh, I have elements making compounds. But in order to make a compound, I need to have more. The third example, this probably is the most complex one out of everything that I have been doing, so let me go with that. Let's say you are making a glucose. I want you to think about how many types of element is required. Do I need 2 elements like in previous situation? The answer is no. You need to have 3 elements. The reason is glucose is C6H12O6. Can you see that I need carbon, hydrogen, and oxygen? So reactants, I can choose carbon, hydrogen, and oxygen. Like I said, in grade 9 level, this is good enough. What you see over here is what I like to say word equation, because, well, we use the chemicals words, aka name. So those are the level that you need to know. Like I said, identify what those types are. The second type is known as decomposition. So decomposition reaction, I like to give a little analogy. Anything that has DE in front, it's opposite of building. Even though it doesn't work all the time, but if you think about deconstruction or destruction, if you think about those English words, the prefix DE, it actually gives you the meaning of you're dismembering something. You're not building something. You already have a structure. You are breaking things into smaller pieces. Like, for example, let's say you have a younger sibling. In Christmas, you receive, I'm going to use Lego analogy again. You built a Millennium Falcon. It took several hours for you, and you made that structure. It is on the display. But your younger sibling who doesn't know, let's say toddler, came and then break those into piece by piece. This is an example of decomposition reaction. So if I generically put that, you can say I start with a compound and I'm breaking that into element and element. Like I said, most of the Science 9, it's binary, so there can be a compound that is combination of 2 of an element, but it can be more than that. So I'm going to show you 2 examples. Some people may say, Mr. Kim, is number 2, decomposition reaction, is exact opposite of formation or synthesis reaction? I would like to say, yes, you got it right. It's completely other way around. So, example. Let's say I have a table salt, sodium chloride, is breaking down into element. I want you to think about how many elements will you have as a product? In this case, it's easy because I have sodium and I will have chloride. chlorine this time. This is the only thing that you need to be careful because sodium chloride, the nonmetal ion's name, chloride, happened because it's used ionic compound's name, which is ending with IDE. However, when it comes to the product, we are talking about element now. So that means you need to put element format of a name, which is chlorine. So if you really want to use a chemical symbol, NaCl, turning into Na and Cl2. As you may notice that I didn't even balance. I'm going to talk about balance as time goes, but as soon as you realize, oh, you know what? I'm starting with the compound, but I'm having element, check, and another element. I now know that this is decomposition, chemical reaction. Ionic compounds are easy sometimes. However, if you think about molecular compound, it is a little tricky. Let's go with an example of molecular compound. Let's say molecular compound. You have an ethanol. Ethanol was one of the chemicals that I asked you to memorize also. I want you to think about its chemical formula a little bit and predict how many elements will we have as a product. Will we have 2 or will we have 3? The answer is 3 because ethanol is C2H5OH. Generally, it's liquid. Well, it is liquid at the room temperature. If you identify what kind of element do I have is, well, we have C, which is carbon, H, hydrogen, O, oxygen. As you may notice, I didn't even highlight the last hydrogen over there because we talked about it in previous lessons that the reason it's written as C2H5OH instead of C2H6O1 is because OH is how it's arranged. That's why. So I like to say ethanol has to produce carbon, hydrogen, and oxygen. So it's carbon, solid, hydrogen, gas, and oxygen, gas, something like that. Is it balanced? No, it's not, but this is Science 9 level. Third type of chemical reaction is known as single replacement. I sometimes call SR. Single replacement reaction, from my understanding, is what students struggle the most in grade 9 and grade 10, even grade 11, because there are 2 different scenarios. So what I mean by single replacement is this. It really depends on what chemical that you're using, but long story short, the generic way is you have element, but you're mixing that element with a compound. The thing is, if we mix elements and compound, one of the chemical that is used to make a compound actually switch its position. So you have new element and new compound. And there are 2 different scenarios that talk about this one. So I'm just going to use an example of it. The first case is, let's say I have a chemical element that is A, and then you have a compound that is BC. So imagine BC is, let's say, sodium chloride, something like that. It's an ionic compound. One of the scenario is A and B switches place. Then what will be the product? B will come out by itself, and instead of A by itself, it's now going to be A and C together. That's one of the situation, and that happened if A is metal. An example of that can be, for example, if I have a sodium metal adding with potassium chloride. Then the thing is, this sodium and potassium, these guys switches place and then produce, instead of sodium, it's gonna now have sodium chloride with potassium. That is one of the outcome. And this outcome have to be happen with metal. Other type is when you have, let's say chemical A, and you have, I just want to differentiate a little bit. I have a compound that is composed of D and E. Instead of A switching with D, they sometimes switch it with E. Some people who sharpen up may already found this outcome. If A element that I'm mixing is actually turned out to be non-metal, they switch the other part of non-metal around. So what I mean by that is A will be now combined with D and A, and E is kicked out to itself. An example can be, let's say I have a oxygen gas that is being added to lithium bromide. The thing is, oxygen is now going to replace the bromide position, bromine's position, if you will. So you're going to have bromine by itself, but now you have lithium oxide, something like that. As long as you identify what type, that's what is important in Science 9. The fourth reaction type, which is known as a double replacement, DR, is actually relatively more, I like to say easier compared to single replacement because you only have one of the outcome. First of all, generically, this is a situation where you have a compound mixing with another compound that will produce new compound, but two of them. Like the word suggests, why it's double replacement is because two ions are replacing together. So for instance, if I have a compound AB mixing with CD, the two of the member, in this case metal and metal, if you do non-metal, non-metal, that's okay because outcomes are exact identical. Then instead of AB, B being with A, it's gonna be now C with B because they change up their place, and instead of C and D together, it's gonna be A and D. As you may notice, everything is compound. There's no elements involved. That's a key point about this fourth one. So a quick example of that can be, oh, let's say I have magnesium fluoride. I have calcium chloride. Imagine I have these two ionic compounds. Well, as you can see, as you can see, magnesium and fluoride, you can switch fluoride and chloride if you want, if you like to switch non-metal, or you can easily do magnesium and calcium switch around. Like I said, result really doesn't change. Then fluoride will be with calcium. Now, sorry about that. For some reason, the recording stopped. Well, let's go back to an example. Like I said, magnesium will no longer will be fluoride, so one of the product will be calcium fluoride, which is a new product number 1, and another product number 2, magnesium chloride. The last reaction type is known as a combustion reaction. You are burning something. This is a unique type of chemical reaction because you have to have this certain gas to burn something, and that is oxygen. So whatever you're burning something, you have to have oxygen. That will create some kind of combination of oxide compound. Normally it's more than one, so I'm gonna put multiple. And it really depends on what make our reactants over here. So for example, if I have carbon, then carbon and oxygen will make CO2. If I have nitrogen, NO2, nitrogen dioxide. If I have sulfur, sulfur dioxide. If I have hydrogen, water vapor. Everything is gas, exception of metal. Let's say I have copper, let's say. Then copper oxide, that thing is solid. If I have iron, iron oxide, that's a red rust that you see. So long story short, it really depends on what makes the chemical reactant. So let's do some example. I'll do easy example, then little tough example. So example number 1. Actually, let's divide into a 2 space. Let's say I have a lot of cases is molecular compound. So what about ammonia? You are burning ammonia somehow with oxygen. I want you to think about how many gaseous oxide products will I have. Ammonia was one of the memorization list. Ammonia was NH3. So if you think about nitrogen and oxygen will make nitrogen dioxide, NO2. What about the other compound? Well, we have hydrogen. Hydrogen and oxygen will make something too. Hydrogen and oxygen will make water vapor. So I have all of those gas and gas product happening. You may wonder why it has to be gas. Well, combustion reaction has a lot of heat, right? So that's one of the main reason why it is gas. It can be complicated too. Like for example, if you have sucrose, you're burning sugar, table sugar. Well, balancing is tricky, but you don't need to. You need to identify in Science 9. Sucrose is carbon, hydrogen, oxygen. As you may notice in here, carbon and oxygen will combine, hydrogen and oxygen will combine, oxygen, will it combine? Well, yeah, but oxygen will be by itself. So you will have carbon dioxide gas and then water vapor gas. And rest of them is balancing, which is what I'm gonna go through just briefly, but not too excessively. Because most of the time in Science 9 it is given. So how can we balance stuff? What is balancing? Well, let's think about its dictionary meaning first. Balancing means, let's say you have seesaw or scale, the left side and right side are on the same level. If one of them is overweighting, then it's gonna tip over to that side. Let's say I have 3 on the left side and right side I have 2, then it's gonna tip over towards left side. That's not balance, that's imbalance. So how can I do balancing in Science 9 level? Well, this is how you do. I'm gonna go through a few examples. Let's say I have a formation reaction. I have nitrogen gas, hydrogen gas, and you're trying to make ammonia gas, something like that. Balancing means ratio. This is how I generally tackle. I look at the subscript and then identify how many chemical do I have. Make sure you use pencil because there are a lot of trial and error. I have how many nitrogen? I have 2. How many hydrogen? I have 2. Now, if I look at nitrogen, the thing is I only have 1 on the right side. That is not equal together. That's not balanced. So that means I can use, we call it coefficient, which is in front of number, like 2x, 3x, 2 times, 3 times. I can use those numbers. So I will actually double everything. Why? Is because 1 times 2 is 2. That's the only way I can make nitrogen and nitrogen balance each other. So that's good. What about hydrogen now? Let's think about hydrogen. Hydrogen is not happy at this situation because on the left side I have 2, right? On the right side, now I want to think about it's 3 and 2. So it's 2 times 3, which is 6. 6 and 2, they are not equal together. But we're not Thanos. We cannot erase something from existence. We can always get something from the outside environment, aka we can increase the amount. So how can I balance this guy? Fortunately, there is a way. I can just triple the hydrogen, because if that's the case, 3 times 2 is 6. So 6 and 6 is check. So hydrogen is good, nitrogen is good, that's good to go. Some people may wonder, Mr. Kim, what goes at the front of nitrogen? If there's nothing, consider that as 1, even though we don't put 1 in front of the chemical equation, we just omit. So the ratio is 1 to 3 to 2. This become a basic idea of conservation of mass, because the amount of reactants that I have, it should be equal to the amount of product. Let's do one more example of balancing. Let's say this time you have a replacement reaction. Let's say single replacement, or combustion. Actually, why not? Combustion reaction is coming out more, and a lot of people are more excited regarding the combustion. Let's say you are burning methanol, CH3. Actually, let's do methane gas, CH4. I'm trying to match with the Science 9 level. If it's combustion, we always need this gas, which is oxygen. We know that carbon and oxygen combine and make a certain gas called carbon dioxide. Hydrogen and oxygen combines and make water vapor. Now the thing is this. We identify what are the reactants, what are the products. We need to balance the chemical coefficient, and in the end, so that the exact same number of atoms exists for the products. It's just rearranging of the chemical. How many carbon do I have? I have 1 and 1, so carbon's good to go. Carbon check. Hydrogen, on the other hand, I have 4 and 2. That doesn't make sense. 4 and 2 are not equal together, but is there any way we can balance the number? The answer is yes, I need to double the water amount. Now let's look at oxygen. Oxygen is always tricky because this is a good example where oxygen on the right side now, if you think about it, is 2 oxygen, and because of this 2 coefficient is 2 times 1 for water, so I have 2 and 2, so total I have 4 oxygen. On the left side, I only have 2, so I have to double that. So the ratio of this is 1 to 2 to 1 to 2 ratio. This is how you do balancing. Like I said, in Science 9, you need to identify what type of chemical reaction, and just know that chemical coefficient affect the whole element or compound that is followed by. However, as long as left side is balanced with the right side, you're good to go. So you may wonder, how does that correlate to conservation? Well, let's think about it. Conservation of mass that I gave you as one of the lesson note is mass of reactants should be equal to mass of the products in a closed system in an isolated system. Even in an open system, theoretically you should have the same thing, but a lot of gas escape. So in PAT exam, what kind of question you're expecting? Well, you will have one of the blank like this, and you need to predict what goes in. It's a basic simple calculation. Right now I have hydrogen and oxygen given 3.4 and 10. If I add it, that become 13.4 gram. All of them should theoretically go to the product. So if there's a calculation question in Science 9, that's the level. If it's a little challenging, well, we need to find the unknown x. Well, we can set up an equation. 12.2 plus 14 should equal to my unknown, which is carbon dioxide, plus 20.0 gram. I didn't even bother putting units in here because the number is important. If I add them together, then it becomes 26.2. That is equivalent of addition of carbon dioxide and water vapor. So how can I find this x? Well, I just need to do opposite operation to other side, which is 26.2 minus 20.0, which give me 6.2. So I have 6.2 gram for carbon dioxide. And ladies and gentlemen, that is today's lesson. And I know it's been a while, but hopefully we see each other soon enough.